Hello everyone, my name is Kelechi Okere. I'm a PhD student at Clarkson University and I'm working with Dr. Kim and Dr. Greenberg, and we are looking at a recovery of nitrogen from wastewater side stream using bipolar membrane electrodialysis. You're trying to understand the fouling in the system and trying to look at ways that we can actually use to mitigate the fouling so we can have long-term operation for the recovery of these nutrients. So let me share my screen so we can actually talk more. So we talk about side stream. In the wastewater treatment plants where we have anaerobic digestion, the digestate that comes from this is actually flown to the belt press where we have the dewatering process. The liquid fraction from this dewatering process is what we call the side stream. It is very highly concentrated with nutrients such as phosphorus and nitrogen. Conventionally, they actually flow it back to the headwork, which actually comes with high chemical costs and, of course, energy increase due to aeration. And when it actually discharges into the environment, it can actually cause pollution. So it's important to find a way to recover it at this side stream. So this is our experimental setup. So we have the membrane model, a one-cell pair. The membrane area here is 100 centimeters square. The feed volume is 300 mL. So what happens in this membrane system? So we have the cation exchange membrane that allows cations to pass and the anion exchange membrane that allows anions to pass. At the bipolar membrane here, we have dissociation of water molecule generating acid and base stream. And at this base stream, by the time we get the pH up to about 9.2 going up, we see that there is liberation of ammonia from this ammonium, which goes into the membrane contactor and diffuses through this hydrophobic membrane. And based on the reaction between the ammonia and the proton as well as the chlorine ion, we have recovery of this ammonia in the form of ammonium chloride. So the problem with this system is actually fouling. You see inorganic fouling happening at the cation exchange membrane and organic fouling happening at the anion exchange membrane. So this actually impacts on the recovery of this nutrient. So for this project, we're actually using voltage rise as an indicator for fouling. However, we also saw that when the conductivity of the sample actually reduces, we have voltage is increased. So it was important to find a way to isolate that aspect of voltage increase. So what we did, we developed a protocol called feed and bleed. So this feed and bleed, we introduce fresh sample into the system and remove depleted sample of the same volume from the system. So this keeps the conductivity quite consistent. So the voltage rise after this is actually associated with membrane fouling. And after that, when we see that, we do chemical cleaning. After that chemical cleaning, we expect to see restoration of the membrane performance. So this actually shows the mechanism of the cleaning. So for the acid cleaning, we see that acid helps to dissolve the mineral scales that actually stock on the cation exchange membrane and turn them into dissolved substances and, of course, gas, as we see from this equation. The same thing happens for the base cleaning, where the cleaning helps to convert the sticky organics into soluble form, which is actually removed finally based on our flushing. So we see consistent voltage profile here. We see consistent ammonia recovery and as well as energy consumption that is actually less than the Haber-Bosch process, which is actually the conventional method for the production of ammonia. So in this project, we see that membrane fouling remains a key challenge during long-term operation. And the fouling mechanism, we are actually able to identify it and we decoupled it by targeted cleaning strategies. And after that, we see that our membrane performance was actually restored. So this study is very important because it actually advances circular resource recovery from wastewater side stream through nitrogen reuse. So let's meet at the conference and talk more. Thank you.